Cool. Okay. We're going through Tute 5 today. Tute 5 is a lot of stuff on promises, and that's good because, that's kind of the topic right now, right? Like we get to week 4, like week 1, it's all HTML, CSS. Week 2, we're like JavaScript. And then week 3 and 4, it's like JavaScript, JavaScript, JavaScript. And people slowly start to get their head around it. Whereas now it's kind of promises, which is asynchronous JavaScript. And the questions today, as well as the stuff in the lecture of week 5 as well, is, to essentially explore that topic a little bit more. I guess as a heads up too, if you're watching this recording or whatever before the lecture, there's a chance there might be some duplicate content given that the lecture of week 5 is open-ended, but let's see how we go. I guess where to start. No, actually, I'll save that for the lecture. Let's just go through the questions and we can get all tricky about it tomorrow. So plus I'll assume most people watching this have either seen the lecture already or know what they're doing because they're watching the recording. But the first question here, just part 1 of promises is like find the error. So we've got this question here called fetch me.html. And this is a pretty straightforward piece of code, right? It's just like a web page. It's got a head, it's got a body, and you see we're using a fetch here where we're fetching that URL. And then on the next line, we're trying to set this dog name to be the data we get, right? So we fetch this data from this URL, we capture in a variable called data, then we set the dog names in a text to be the value of data. Now I'm going to go and open that file for you. And what's going to happen here? I mean, again, the 2 people in the call, I know that you're relatively capable. So you'll be like, this is boring, but let's do it. Fetch me.html. Yeah, so if I open up this page, you can see here that it's filled the actual div with this random object promise, which is kind of annoying. You can actually see the div has literally been filled with that. And the reason for that is if we go to our console and we actually start, console logging this, then what Nicholas has said here is that data is a promise and it's not yet fulfilled when data is used on line 8. Yeah, so you can see here that when I load this page, why is it not printing out data? That's weird. Oh, use a capital. Off to a strong start. What do you mean by used a capital I? Both capital L's. I don't think. Oh no, that's just the weird font. I think that's actually funny you point that out. That's just like the weirdness of the font. Is this even the same page? Just triple check. What? Am I loading the wrong file? I'm so confused. Dev CS6080 content/tutorials, tutorial/content/tutorials. Oh, okay, sorry. Too many folders on my computer. There we go. Content. Okay, there we go. Perfect. Okay, so you can see when we print this, we get promise and it says pending. And we've talked about this before. What this means is that at the time this was printed, well, at the time we tried to print it, the promise was still pending, basically, right? Now, what that means in reality is that, again, if you imagine your code, in some kind of 2D space, you have a line here, which is like your fetch, you have your console log, and then you have your DOM manipulation. Now, again, if you're working with your imperative programming that goes like, it does that line, then that line, then that line, in theory, you should get something from the fetch, which will then manipulate the DOM. But remember, in Node, there are a whole bunch of commands that are asynchronous, which means that you'll hit this line as you're going through the lines. And when you hit this line, it says, hey, I'm about to do something that might take a while. So instead, I'm going to go and do it over here quietly, and you keep on going. You go to that line and you go to that line. And this might still be processing over here by the time all of that code finishes. This is just how JavaScript is essentially written. It's cool once you get used to it. The main reason for this, and you'll actually see this with quite a few different languages, is that one thing about JavaScript is that it is a visual tool, right? It's used to render stuff. And where this differs is that, and if you've ever done Android development, you'll actually see this as well, is that if you try and develop an Android app, for instance, and you get which is say Java, and you get like your main screen, and then you try and do a fetch as part of the main screen, it will actually say to you, sorry, but you have to make this fetch asynchronously. You can't just call it, because if you think about your program as a single thread, then if this was blocking here, by blocking we mean that if the code executed imperatively, but it literally stopped here and it waited that whole, let's call it 2 seconds for the network request to finish, then the DOM wouldn't be updated. And in fact, it would block everything. So single threaded UI applications aren't really that helpful, because everything will just have to wait. And that means that, like, think about all those buttons you click and stuff. If your whole program was just waiting on a fetch to complete, none of the buttons would work, because it would all be like super queued up and super sequential. So this kind of like threading notion, or this asynchronous notion, is super useful. I don't want you to get confused with like multi-threaded processes either, because Node is single threaded from my understanding. It's just that within that thread, it's happy to jump around. So that's where that whole topic of the event queue comes into play, whereby Node is still single threaded. It just kind of might seem multi-threaded because it's comfortable jumping between different things and tackling different things. So yeah, this fetch here returns a promise. We know that already. Now, how do you deal with promises? Most promises you deal with by the same thing, which is you say the syntax is promise dot then, where you give it like a success function, and then a dot catch where you give it an error function. So in this case, we could follow the exact same principle, where we could say, well, this fetch is the promise itself. You could either use this particular piece of code, or you could use the data, which we'll do here. We'll say data dot then, and then we'll say success function dot catch error function, like this. And then we can go and define what goes into these two things. Now, what this means for the program is that JavaScript will, create this promise, which is an asynchronous piece of work to be done and fulfilled later. And then you say to it right here and then, I know you're not finished yet, but when you are, do this. And if there's a problem, do that. So we could go and define those two functions separately if we wanted to. Again, this could just console log yay, and then we could have an error function that would just say console log like nay or something like this. And then we'll get rid of the DOM render for a second just to get used to it. So yep, it prints yay. And then if we have an error in the URL like that, it'll print an error and then nay. Now, actually, this is a good point, because if you have fetch errors, if there are errors that are like 404 or 400 or 403 and stuff, 502, your browser, if you're using Chrome, will typically give you these red errors no matter what. So if you're using Chrome and you get those red errors, don't freak out. It's not like you've done something wrong. That is not caused by you. That is just the browser saying it just will do that anyway. So don't worry about that. So there's your success case and your error case. Now, typically how you'll see these written a lot of the time is you'll see them written something like this, for instance. Or often you'll just kind of maybe even skip that whole data thing, because data is just a promise. It's not actually the data. So it's like, what's the point of that? Like, the only thing you're going to do with a promise object is either call dot then or dot catch on it. So we can just get rid of that altogether and just say fetch dot then dot catch, like that. Now, again, what you could do is, of course, anonymize these just to keep things even cleaner, and say, put that there, and, put this here. And then because they're functions, you could break them onto their own line as well. So this would be perhaps like a pretty normal way that you would see people interact with promises like this. Except what we want to do in the success case is we actually do want to update the DOM. So instead of printing yay, we'll actually set the dog name to data. Now, what is data? Well, every promise, when it calls a success function, it actually gives it the data that has been compiled from the promise, right? It's a little bit incepty, but You know, this should still work here. Nay, because I screwed up the URL. Okay, so we're still getting object response. So why is that? Well, let's console log that, right? So we get this and the data we get, and it's like, oh, okay, because when a fetch is finished, like remember, promises is a broad concept to deal with asynchronicity. Fetch is a network request that simply returns a promise because it's an asynchronous function. So the fetch returns a promise, and once that promise resolves, is then once that asynchronous work is done, it gives you back a response object. So this is the resolved promises data. And you can see there's a whole bunch of stuff in the status codes and all this other stuff. And again, we looked in the lecture the other day that if you want to extract particular pieces of information from that, you could look at like fetch response API. You could Google this. Response is an object that's part of the fetch API, right? So you can see the response interface represents a response to a request. And you'll see there's a whole bunch of stuff on here. So it has a bunch of properties. These are just variables and fields like body, body used, headers, okay, redirected, status, trailer, type, URL. So it's like, let's just try and print URL and body. Maybe that sounds interesting. So I'll print data.url and data.body. Okay, so data.url gives me the URL, and data.body is not what I want. I wanted like, you know, text or something, but it's giving me this readable stream thing. Now, again, this is just by design, is that because you could imagine some pages might be absolutely massive. So rather than just like storing a whole chunk of stuff in the response object, it's kind of giving you a stream access to it. Sorry, I got the hiccups. So to actually read from the body, we can't just access the body element because we'll get a readable stream. We could probably read from that stream if we wanted to, right? Like we could probably do all this stuff, like get a readable stream and read from it and like all of that and close the stream. But that's like kind of complicated. So the response object does have a series of methods that are useful. For instance, it has a .json method that returns a promise that resolves with the result of parsing the body text as JSON. So that means if your body text is JSON, as you've probably seen in assignment 2, this one's super useful. So if you know the body of the response is JSON, it's like this will just convert it for you. And then you have ones like this, which is .text, which is simply returns the body as a plain text, result. So if I Google this one again, you can see that this web page is just the word Cato. So therefore, that's the responses text. So that's the kind of thing I'm interested in here. So what that means is that data.text, what does this give me? This gives me a promise. It returns a promise that resolves to the text of the body itself. So what do we know about promises? This will execute asynchronously, which means that the code will keep going. So therefore, we can't capture it like this. We can't say that, and this won't work. We're just going to set this to be another promise now, right? Object promise. If you try and print a promise, it prints out like that. So that's why you get that kind of behavior here. So you need to do what you did before, which is you say data.text. This is a promise, and then you're going to dot then on it with some kind of success function that might say take data, call it data2. And obviously that's going to give you the text itself. Dot catch, console log, you can, need to something like this. And now you'll have a page that actually prints Cato. And you can see again, you can see that slight delay. In fact, we could probably document that slight delay by saying console log here, new date dot to what is it? String, what is it? New date dot to, I feel like my JavaScript date to string, is it to? Oh, let's just try to string. Let's see if this works. Let's print the current date at the beginning of it. It might give me an actual date though. 205. I want something more granular. JavaScript date milliseconds. Date dot now. Okay, date dot now. Oh, no new date. It's just date.now. It's a static. Sorry. Yeah, Cato. Okay, there's our milliseconds. So like if we print this one out as 1, again, just to step through it, and then we print this one out as, say, once the first request is returned, let's print this out as 2. And in fact, let's actually, yeah, let me try and like really spell this out. So let's say that like const starting point is date.now, which will give me the number of milliseconds since 1970 or something, right? And then what I'm going to do is I'm going to print out 1 as 0, because when we start at the start, there's been no time has elapsed, theoretically. And now what I do is at each of these points, let's print date now minus the starting point, so we can actually see how many milliseconds have elapsed since these points. And I'll put this one here after the first promise resolves, and I'll put this one here after the second promise resolves, and I'll put this one here at the end of it all, so we can have a look at how all of this pans through. Okay, so again, you can look at this and you can see that what's happening is that it goes 1, 4, 2, 3, because we hit here, the fetch starts, the fetch happens asynchronously. So think about that like side work, and then it just keeps going and it jumps straight from here to here, because these two things are really quick to run through. This first fetch takes a moment, it returns here with a 2. The second fetch takes a moment, returns here with a 3. So those things take time. And in fact, you'd be able to kind of follow this as well if I even put like more things, say, after this promise here. So, you know, let's say I put like a 5 here and a 6 here. So if I actually just put this code in our code, that's like totally in line, you know, like 1, 2, 3, 4, 5, 6, and I refresh this, you can see it goes 1, 6, 2, 5, 3, 4, which is like super weird, right? But it makes sense because you are going 1 promise sideways, so you do the 6, then this promise finishes, and then you go and execute this block here, which goes 2 promise 5. This promise finishes, so you go 3 dom 4 like that. Yeah, easy enough. Nicholas asked a good question. Do we have to catch at each level of encapsulation? Well, let's try it out. So let me get rid of these console logs because they're a bit of a distraction. Oh, let me get rid of the numbered ones. So let's have a look at this. If the URL, actually, sorry, just to be clear, just to have some fun, let's do 2 nested promises, but the second promise, I'm actually just going to do another fetch because it's easier to kind of check errors and stuff here. So if I refresh this one, you can see this actually does work because it does the first fetch and the second fetch. If I put an error here by saying a file that doesn't exist, so it's going to get a 404, you can see it prints out nay. If I put an error here, you can see it's going to print out nay 2. But let's remove this catch and see what happens here. So what happens if I don't have this catch here? Okay, nothing particular happens here. It says uncaught in promise type error failed to fetch. So without this catch here, it's not actually going to handle this then correctly. And similarly, you know, if I didn't have this catch here, and there was an error in the second level, it will work because there's an A2 here. But if I say create an error there too, it will throw an error because there's no catch there. Now I'm sure, I can't remember off the top of my head, it's like promise, catch, rethrow. I'm sure there's some kind of rethrow in with promises. I don't work a lot with promises directly. So some of these things aren't on the top of my head. But there's probably some form of rethrow syntax that I've just forgotten. Yeah, it looks like you can rethrow it. Now that's not super useful because you still have to write the syntax there, but you know, that might be more if you say have something like this and you just want it to all get caught, you know, you could say throw error here after you catch the error. I think that's what this one will do for us. Nope, that one didn't do it. What are we doing wrong? Yeah, both then and then in catch return methods return promises. And if you throw an exception either handler, then the return promise is rejected and the exception will be caught in the next reject handler. Following code, blah, blah, blah. Now, One thing that's different here, one thing that's interesting about the approach we've taken is that we've kind of used these nested promises here. Whereas another type of syntax you might see people using, and again, we might run through this more tomorrow, is that you don't need to nest promises like this necessarily. You can also do what we call promise chaining. Yeah, I probably should be throwing you error. I was just playing around with syntax, seeing if there was any easy wins. You can play around with chaining, where what you actually do is, if we kind of take a step back here, and we look at, okay, fetch. All right, well, what happens when this is done? A common way you will see promises also defined is like this, where it's just like fetch dot then dot catch all on the same line. And part of the reason for this is that if you, in this particular scenario here, say something like, instead of dot fetch dot then, if you actually say return fetch, I believe this is what it is, you can actually start chaining these promises here. So I'm just going to finish this off here, where I might say, console log data2, because let's try and actually print this one out. Oh, unquote syntax dot, oops. Cool, so we've still got errors here because of the damn URL. Let me fix that up. Okay, so what you're seeing here is you're actually seeing it be successful. This is kind of like a cleaner way of dealing with promises and the nesting thing, because the way it works is that when you return something to a dot then, if you return another promise, once that's resolved, it will call another dot then on a dot then. So you can basically chain dot thens together if they're all kind of like one after another. So for instance, what were we doing before? Well, we were saying that we want to return data.text, right? Because data.text, what does this give us? This gives us a promise. But instead of doing, data.text.then and all this kind of stuff, we can actually just say return data.text, which we know is a promise. And once that promise resolves, we will go on to the next dot then, like this. So we'll actually get Cato like this. And this is somewhat cleaner, right? This is definitely a somewhat cleaner way of dealing with things, because then everything's caught by that same exception here too, because it's like all of the thens in this chain is caught by this. So if there's any kind of exceptions in this chain, it'll be caught by that catch. That's another reason why chaining promises is usually a good approach here as well. The other note on this is that remember that the dot thens, they only take in a function. So you think about, say, something like this, where you have like, what is this? Right. Well, let me break it out for you. Let's say we do this, where we say, const fn equals that. Now this makes sense. Fn is a function. It takes in a variable called data. It returns data.text. But the thing is, what this is actually doing is this is just a function that calls another function, right? That's all it does. So you could actually even simplify this further and just put data.text here. Because think about it, dot then is passed a function and it returns the result of that function. So if I give it fn, what it actually does is it goes and calls fn and gives me the result of that. That's what that does, which is a promise. So if I just give it data.text, it will actually go and call data.text. But data.text isn't taking anything. That probably won't work, actually. I don't think that one works. I think I got my example mixed up. Yeah. This works for functions where you, trying to think of an example of what one you'd see. Sometimes you have particular promises that there'll be functions like this, where you have a function that called data.text that takes in data, and all you're doing is wrapping a function around it that takes in data and passes it to it. So it's quite a literal benign abstraction. Whereas like in this case, you can't really do that, but that's okay. Typically you'd keep this nice and short anyway. You'd say something like, data, just return data.text, like, return data.text like this. Except again, you would probably often clean this up to make it more readable. So with something like that, if you ever have single parameter functions, you would typically just get rid of the parameters, make it look a little bit cleaner like this. And if you have your function, its sole purpose is to return one thing, you can drop the return and the braces and actually keep it even simple like this. So, and again, same thing with the console log. Console logs technically don't really return anything. So like, you don't need to worry about it, but that's probably what you would write. Like this is at the stage now where it's like, yep, this is how I would do those promises. And you can see that's actually pretty like clean because, you know, promises can get pretty unwieldy pretty quickly, right? But this is relatively contained. It's like, all right, well, we want to fetch that. Once that is done, it's asynchronous stuff. We're going to call this function, which just returns another promise. Once that's done, we're going to call another function that just console logs it. Or, you know, again, to keep it even easier, you know, we got our document get element by ID dog name dot inner text equals data2. And then there you go. And again, similar thing here, you could simplify this too. Nice and easy. Nicholas says, which statuses cause the response.ok to be true? Oh, well, I don't know, actually. Probably two XX errors, I would guess. Yeah. A Boolean indicating whether a response was like one of the two XX errors, is in 200 to 299. Does fetch catch all errors or certain types? I'm not sure what you mean by like, does fetch catch all errors? Does catch all errors? Yes, it does. It catches all errors that happen here. You can capture the error and print it out too. So for instance, if I capture this error and print it out as part of my console log on my page here, and I change this to something invalid, it says failed to fetch at that. So that's the actual error you're getting there. So, you know, it definitely wasn't successful in that particular case. All right, I mean, let's move on. Timeouts and promises. Oh, I like these ones because they make you think about promises a little bit more. I'm just having a look at the rest of the questions here too quickly. So question 3 is just about accessibility. That's like a fun question where you just look at the McDonald's site and you point out terrible things about it. Maybe we'll try and do that quickly at the end. And then we have another example, which is like, how do you build a website with like different tabs and stuff? I don't think this one's super critical because we kind of did this at the end of the lecture last week. If you've seen the lectures where we were like, oh, this is how you make multiple looking pages on the same page. That's all this activity really is. So it's more fun with other tutors because they'll actually do it a different way, right? Like they'll actually be like, this is how I would do it. And that'll make you think, whereas I'm just going to spit the same stuff out. So we've got this file here with some promises. Now, we could do this in a web page. We could do this in a Node.js script. It doesn't really matter. You know, let's just do it in the JavaScript page. Why not? Because it's easier and we have that up. But we could do it in a Node script as well. I will just indent everything down. So you can see here, this is about creating promises. But before I get into creating promises, let's just quickly talk about timeouts. So JavaScript has a function called set timeout. I think set timeout is an excellent function because it makes you think about callbacks, which is like one of the kind of more fundamental asynchronous parts of JavaScript. I'm just having a look at different tute questions because callbacks can be fun. So maybe we can have some fun with callbacks. Maybe let's do a little bit of that quickly. So in terms of callbacks, set timeout is a function that takes in a function and a time. So you give it a function like const fn, which is just going to console log hello, and you give it that fn and you give it say 1,000 milliseconds. And then what happens is when this gets hit, after 1,000 milliseconds runs, fn is triggered. So I refresh the page, bam. If I make it 2,000, it's 2,000 milliseconds. Refresh the page, bam. So now the cool thing about set timeout is it's what asynchronous programming really is. This program is happy to keep running. I can console log 1 here, I can console log 2 here, and it will all just 1, 2, hello. So that ran kind of non-linearly, right? Now, again, most of the time people will define these functions anonymously like this. That's how you'll tend to see it. So it runs kind of non-linearly. the way we get around this with JavaScript, of course, is that we don't pause, we keep going, and this just happens later. Whereas if you get something like Python, there's like a sleep function, right, in Python, which suspends the current thread for a given number of seconds. Now, Python by default is multi-threaded. So it's like, Python is by default, you have to create more threads. So if I have like a Python file here called blah.py and I python 3 blah.py, it like waits. It actually waits. It runs linearly. Here it won't. It'll do all that. You can still do this with Python, but it's kind of just not the default behavior. There's nothing special about this. It's just how it's baked in from the start. So we have these timeouts. Great, cool. They make sense. You can do some cool things with the timeouts, which, to be honest, we probably have some time for, which I can maybe show you quickly. Like, kind of a common question is, I'll show you a quick problem. I have a feeling that this is somewhere else in the course, but I couldn't find it in Tute 7. So I'm hoping that like I just made that up in my brain. But a kind of common problem you actually get to do with fetches, and I'm sorry if this comes up later, but it helps demonstrate timeouts and fetches and stuff, is probably in an exercise is where I'm thinking about it, which we don't mark anymore. But let's say you have a field, like let's go back to the Cato example for a second. The doggo thing. It's like something you see on websites sometimes is a search bar. Input type equals text. And then like, this will just be a search bar where you can search for some stuff like, hello. Now, if you want to build a nice modern dynamic website, you would like to be able to type stuff in and it just do things. You don't want to have to click search or anything like that, right? Like this happens with Google all the time. So how do you do that where you kind of, they don't have to click, I'm done? Well, how do you know they've finished typing? Well, you don't. So what are your options? Well, you could have it call a fetch on every single letter click. All right, so I give this an ID, like search box. And then I just JavaScript myself, document.get element by ID, search box, dot add event listener, key up. Okay, there's my key up, great. And then I'll just say like search for e.target.value, which is going to be what's going to be the is the event. So that'll actually give me what's in the box. Now I got A, B, C, D, E, F, G, like this, what is my height in centimeters? Now here's the problem with this. What you notice about this is it just went and made like freaking 15 requests or something because you had all these different letters here. So that's going to be really bad for like network reasons. So you could imagine for a second, let's say that I call this particular fetch here, right? And then when it's done, every single time it's done, I'll just like, update the doggo thing for a second. Now this works, and generally speaking, this works because it's like a CSE server, which is really quick. And you'll see here, like, look at all the network requests I'm making. Like that was just like dozens of requests to a CSE server. Now, granted, it's probably caching some of these, which probably helps a lot. Whereas like it is caching these, that's why it's so quick. But if you're calling an actual server that actually needs to look up a database or something, and that might take a second, these things all just like stack up on each other. And eventually browsers as well won't actually run this many requests in parallel, and it gets really slow. So it's kind of a common problem. So a way to get around that is to use a slight timeout. So you might say here, let's just wrap this into a function called const populate search. Now, granted, this page just gets a text file. So like we'll have to pretend for a second, and we'll say that the texter gets passed in as like search string. And yep, it does all of this. And what we'll do is we'll just call populate search with e.target.value. So that's us searching it. However, what we can actually do here is we can actually use a timeout. So what we can say is that when someone keys up, let's actually wait like maybe 0.2 of a second before we send off the request, just in case they type something more. So what we'll say is we'll wait 0.2 of a second, and after 0.2 of a second, we'll populate the search. Okay, now all this is going to do right now is it's just going to delay things very slightly. ABC. Oh, I didn't console log anything. Oh, it printed up. I might just actually console log the Cato thing here, just so you can see it. Or even better, I'll just console log date.now so you can, see it being live. Like ABC, ABC. There's just like that slight delay, right? Without that timeout, it would be nearly instant. It would just be like, bam, done. It's not much of a delay. Maybe let me do half a second. So this is better, but it's like if I write how are you now, they all still come through. They're just delayed. When you call set timeout, it actually returns you with kind of like a little pointer or a little, unique ID, which is actually like that timeout itself. And you can actually cancel that timeout if you say something like, let timeout equals that, and then you call clear. Is it clear timeout? I hope it's clear timeout. So if you actually get what set timeout returns and then you call clear timeout, it will actually cancel that timeout altogether. So when we do something like this, it's canceling. And so it's kind of setting the timeout, immediately canceling it before the timer even runs. So what you can actually do with this is play around with it a bit and say, you know what, let's set timeout to be null. Let's clear it as soon as the key up is pressed, and then let's set a new one on top of it. So it's like it's by default blank. You key up, so it clears any that exist. So it stops any ones that were waiting in that 500 milliseconds, and then it sends it out. So it's like, great, okay, ABC, one request. How are you? Another request, and you can toy around with this depending on, how fast people type, like, how are you? So that one actually triggered too, right? Maybe that's a good trade-off because you got to play around with this sense of responsiveness with, how much kind of heavy it is. Because you can imagine slow typers here are like, if someone's trying to search up light bulb, oops. Like, look, you're basically doing a request all the time. But if, maybe do something like 1,000, it's like light bulb. There you go. Yeah, anyway, that was a little segue about set timeouts. But so hopefully that gets your head in the mind space of it. What we're interested in now, though, is actually creating our own promises. Because here's one of the problem with timeouts, right? Timeouts are just a feature of JavaScript. They're not promises or anything, right? They're actual just functions that have like a delayed calling. A promise is an actual kind of data type. So I can't really do something like set timeout 1,000, right? Dot next, dot then. I don't really have syntax for this specifically, right? It just doesn't really exist because set timeout's not a promise. It's set timeout. It's the universal JavaScript function. So I can create my own promise like this. This is how you create your own promises in JavaScript. You say that I want to create a new promise, and let's break this down piece by piece. So const promise 1 equals a new promise. So promise 1 will be a promise now. What does promise take in? It takes in a really simple function that is just A, B, and a body. And what A and B are is A and B are the success and the failure functions. In reality, what that actually means for you here is that if you then say promise 1 dot next, dot catch, this is actually what happens. So when you define a promise like this, the function you give it is saying that, actually, I'm probably just confusing you here a little bit. Let me just copy this out. So what happens here is that you have a promise, and that promise takes in a function. The resolve and the reject are both of them, they are functions. And they are the functions that are called in the dot then case and called in the dot catch case, right? They're the functions that you call in those cases. Sorry, I've just been getting so many phone calls today. It's really annoying. So what happens here is that we actually set this timeout like this, right? 500 milliseconds. And then once it's finished, we call resolve. All right, so what's actually happening with resolve here? Well, if I go and say, do something like this down here, promise 1 dot then console.log data, this is where things can get really interesting. And I load this page up here. You can see it's actually printing 1 after half a second. And that's because what's happening is that we are creating a new promise, resolve reject. And when this promise starts, which it, pretty much starts whenever you say promise 1 here, we do call set timeout, and then we call resolve. Now remember, resolve here is the function that's passed into .then. So like this is the resolve function. So when the promise is, so what happens is you call resolve within the promise, and then it's like, bam, I'm going to call this function here. So this is what is called if resolve is called in the function, in the promise. If you call reject, you get the opposite thing. So for instance, I have this like console log data here, and then I'll like console log the error. If instead of resolve, I actually call reject and say sad face, then I've got then what happens is we actually get the sad face. It says uncaught, dot catch. That's why it's uncaught. Sad face. So resolve and reject here are actually what you're using to essentially like dictate how things go, right? And it's like, okay, well, you're like, what do I do with this? Well, it's like, let's say you actually want to make your own promise-based timeout function. You could do that pretty easily. You could say, I'm gonna give you a function, right? And I'm gonna give you a timeout. So functions like the function you want to call if it succeeds. I got to give it a name. I call it like my set timeout. Nicholas says, do resolve and reject only take 1 argument, or can you give them multiple? You can give them multiple. So like, I'll show you what I mean here. So it's like your my set timeout. The thing is that if you want to use this in a way where you say, my set timeout, where you want to be able to say, here's my function. My function is to console log success, or like, actually, I don't think we need the function. Sorry, let's just stick with the timeout. So say you have something like this where you just want to say like, my set timeout for 1,000 seconds dot then console log success, or dot catch console log fail, like this. It's like, to do that, well, this is a promise, but you can't really use set timeout here because set timeout isn't a promise. You can't really just say, oh, I'm just going to like return set timeout, because that's not going to give you a promise that you can do .then with. You actually need to return a promise. So that's like a really important thing to keep in your head. The .then, .catch stuff, they're all promises. So your my set timeout function needs to return a promise. And what this promise is it's saying that I will execute this. I will execute a set timeout. And after timeout seconds, I will call resolve. And in fact, in this case, let's not even give it any arguments. Let's just give it blank. But if someone say, this would be a terrible idea, but this is a really simple function. If say timeout is greater than 2,000, I'm actually going to reject it. So you might do something like this, say, where you say, you know what, if the timeout's greater than 2,000, just reject it. And if the timeout's less than 2,000, then we'll set a timeout and then call resolve at the end. So now we've essentially made a timeout promise that will call my function after that amount of time, or if I ask for too much time, it will simply fail. It's complaining I've got what, too many brackets, something. What's the problem? 36. Can't read properties of undefined. Oh, not returning. Thank you. Return new promise. Yeah, so it's like just creating a promise is not going to do anything, right? Like you have to actually return it. So you might be thinking it's like, all right, well, what happens if I just quickly, it's like, 1,000 seconds. What happens if I do this? If I say that that's my set timeout 1000, will that actually trigger anything? No, it won't. So it's like the promise is really only triggered. Look at return again. The promise is really only triggered. Got to get rid of this. The promise is really only triggered when you actually like invoke the dot then on it. So like, just because I do this, just to be clear, this is not running a promise. This is just creating a promise. So like this function here creates a promise for me. And this is a promise, but I haven't kind of like executed it yet, waiting to be fulfilled. Whereas when I do this syntax and I put the dot then on it, the dot then is quite literally a function that says, let's execute the promise now. And once it's fulfilled successfully, I'm going to call this function. That's all the dot then is. Take this promise, execute it. When it's done, call this function. Great. So you take this promise, you execute it, which will execute this here. If timeout's greater than 2000, reject, otherwise resolve. If I give a timeout of 3000, it will fail immediately, right? So it'll like quite quickly, just fail. Now, can you give a promise multiple arguments? Yes, you can. For instance, here, I could resolve, and I could resolve with, say, date.now, which is when it finished. And I could also resolve with, say, timeout if I wanted that information. And if you pass those two pieces of information through the resolve, where you actually catch it is in the dot then here. So I would actually pass like timestamp and timeout here like this. And then I could print those out, key stamp, timeout, like this. Right? There's the timestamp, and then it's undefined. It's actually really interesting why it's undefined. Why is that undefined? Oh, yeah, sure. That's interesting. That's a whole fun topic for later. Do I need bind? Yeah, I mean, you basically have to bind it, or you could put a closure around it or something, but I'm probably just not going to jump into that. But it's like, hey, let's start with that. So that's actually what happens. So when this promise here is executed, it doesn't return anything, and I think this is probably one of the most important conceptual elements of a promise. This promise function does not return anything. It simply either at some point or multiple points calls reject, resolve, and reject. You can call resolve and reject many times throughout this function. That's totally up to you, but it's like you call resolve here and it will simply call the dot then. If you call the reject, it'll call the catch. So what the benefit of promises are, because there's always kind of this question, it's like, what's the point of promises? It's like, it allows you to work with things asynchronously. It allows you to do things like set timeouts, or you could even use it to work with DOM elements or file openings or something else like that, quite conveniently. Now, that being said, there is a wide array of things in JavaScript that uses promises by default now. So for instance, fetch is a good example of that. Fetch is simply a, it tells you here, right? What does it say? Promise. It returns a promise that resolves to a response to that request as soon as the server responds. So you can see that like more and more JavaScript's kind of built up on this. So understanding how to write a promise like this is really useful in helping you understand what's actually happening. Like for every promise I use in JavaScript, for every 1,000 promises I use in JavaScript, I probably only write one. It's not super common to write it, but it's very useful to understand, at least from my memory. The first time I had to write one, I was like, oh, okay, I kind of get what's happening here now. Yeah. So anyway, Nicholas, you can give it multiple. That's why your resolve function pretty much needs as many arguments as like the promise resolves with. Like that's why with yeah, like I don't know where it's specified in the docs. Fetch. So it'll probably tell you here, right? Return or something. Yeah, return value. It's just a promise that resolves to a response object, not to multiple. Most promises resolve to one object. I think that's just kind of convention. So when they say it resolves to a response object, that's why in our like earliest examples here, when you're done with the promise, you would typically call this response or something, because this fetch is a promise that was called, and as part of it doing all its random callbacky stuff, it randomly eventually got the request back, and then it simply called the resolve function with the response object that we caught here. And then when we called response.text, which was calling the text method on the response object, it called a promise, which eventually somewhere in it, while it was running, had a resolve object that just returned the text itself. So that's how those work. Anyway, I hope that's been useful. In the last few minutes, I'd mainly be curious just on what you hear. What's still confusing to you? What did this clear up, if anything? Just anything like that. It would just be good to get an understanding. It might have already made sense too. Like if you're neck deep in the assignment, besides the writing of promises stuff, I imagine it's all pretty similar. I'd never used promises explicitly before as in the new promise syntax. Yeah, so the times you'll encounter the new promise syntax are pretty much any time you might want things to happen asynchronously. So like a quick example of that might be I don't have a lot of time because we're near 6, but broken car outside my house. It's weird. Yeah, so like, let's say, for instance, you want to do something like this where you want to be able to call populate search. But the thing about the actually, or I should call this like, oh yeah, give me dog. This will be my last example because I think this might really demonstrate where promises might be useful. So you have something here like give me dog. And what you want to do is like have this function where you can actually get that dog result. The problem is like, this function made sense before because it was so static with what we're doing. We were just like, hey, go do this. And it just went and did it. And we were like, I don't care what happens to you, right? Like once you call the function, you don't care what happens to it. It'll just go do its thing or it'll do its other thing. But what happens if you actually want to do something, like want to call something asynchronously, but get something back from it? Like as in, I want you to actually, no, I want you to give me what's at this URL. Because we can't really say like, okay, well, now that you've gotten the text, can you return text? Like you can't. So this is where you would actually probably have to return that whole fetch kind of thing. And this is what you would do, right? Is you might, I guess you just do that. And then you do get me give, okay. Dot then, oh, you call that. Dot then and then like D console or D, something like this, maybe. See what this gives us. Cato, right? Now that's like kind of what you would do there, but what'll happen is sometimes you maybe can't return that outright, or maybe you want to do something else to it. So maybe a do something else to it example is like once you actually get the text, you might want to say be able to return my name is Cato, right? Like this. You might want to return that, but again, it's like, how do you return that? You can't. Well, you could like return more stuff here and blah blah blah, or if you want to, you could wrap this whole thing into another promise itself, where you could say, actually, when you call get me give dog, which I want to be able to call, it doesn't really matter what the string is, and then I want to be able to say, result as like console log result. Like this is what I want to do here. This won't work with this because obviously. Oh, it does. Oh, of course this does, right? I've been making this up. So like this example works fine because it just returns the text. And if you return a non-promise, it just resolves. But my point here is that you could, if you need to do something more interesting, which I don't have an example for you, you could just have this function return a new promise, which is just a resolve reject wrapper. Like the code I just wrote is very stock standard. You actually put your fetch and stuff inside of it, but instead of returning something, you can actually just call resolve here like this. And this is kind of like how you would get around that syntax because, and again, I'm sorry that in the making it up on the spot, I don't have a good example for you, but it's like, that's where writing your own promises comes in handy, because sometimes you want to do something with other promises or other callback things like timeouts, and you'll just be like, how do I turn this into a function that I can use? And that's where you just wrap it in a promise like this. And then you're like, ah, great. I've got the give me dog thing, which will, give me a dog. It's a nice little abstract function. So that's probably the only time in summary I can think about you writing your own promises, is if you want to kind of create your own little helpers in this assignment that are made up of other promises. But as you've seen before, just because you chain promises together doesn't mean that you have to create a function for it. Promises are pretty versatile in that way. Anyway, it's 6 o'clock, so I don't want to take up more of your time. Hopefully that was interesting or useful. This part 2, which will come out on Friday, this is about how to process multiple promises concurrently. Maybe we'll talk about that tomorrow, because again, tomorrow night is open-ended. I'm sorry if there is some repetition tomorrow night, or if people are watching this tutorial after the week 5 lectures, if this was repetitive too. But anyway, have a good evening, and thank you for coming along. It's nice to see you both.